Algebra 2 Semester Final Review Unit 1. Since there's limited time in the classroom, what I'm going to do is go ahead and do the odd problems that you're responsible for your homework, so that if you don't have time in class to ask your questions, you may have time to go ahead and download these videos and check over your homework to make sure you understand all the concepts before we take our test next week. So for problem number 1, it says we want to work on order of operations. So the first thing I want to do is look at the parentheses. 6 minus 3 is 3. Then the next thing I want to do is my exponents. 2 to the third is 8. So I've done my exponents. Now I want to do multiplication and division from left to right. So 8 divided by 3 is 6. Then I want to go ahead and do the multiplication. 8 times 4 is 32. And then finally I want to do my addition or subtraction. And all that's left is addition, so the answer is 38. On number 2, again, another order of operations problem. I don't have any parentheses, but I do have exponents. So 5 squared is 25. Now I'd want to go ahead and do my multiplication. 4 times 25 is 100. Now I would go ahead and do my addition and subtraction in the numerator and denominator. And then I would want to reduce, since it's possible. 8 doesn't go into 108, but 4 does. 4 goes into 108 27 times. 4 goes into 8 2 times. So a reduced answer would be 27 over 2. Or if you're using a calculator, it's 13.5. Number 4, evaluate the expression. We want to substitute in a negative 4 for the x, a 2 for the y, and a 1 for the v. Make sure that when you substitute, you use parentheses. Now, negative 4 squared is going to be positive 16, but because there is a negative in front of the parentheses, this first step of doing my exponents is going to leave me with a negative 16. Then I want to go ahead and do my division. So negative 6 divided by 2 would be negative 3. Now I want to go ahead and do addition and subtraction from left to right. Number 7. The indicated operations here is that we need to remember the distributive property. So 3 times m is 3m. 3 times negative 2 is negative 6. But we also have to remember to distribute in this negative 1. Negative 1 times negative 5 is positive 5. After we've distributed in the 3 and the negative 1, we want to combine like terms. 3m and negative 2m is m, and negative 6 and positive 5 is negative 1. Number 9, another distributive property. And then combine like terms. Number 11. Now, several ways we can do this problem. First of all, you may see that we could factor out a 2 in the first term, which would leave us with the 4x minus 1 over 2. Then there's a subtraction. And as you can see from the second term, it looks like we can factor out a 7 on the numerator as well, which leaves us with the 6x plus 2 over 7. Now that we have a 2 and a 7 in front of our parentheses, we could reduce. 2 goes into 2 one time, so I'm left with 4x minus 1 minus the 7's reduce, 6x plus 2. Use parentheses because it's very important that we distribute in this negative 1 before we combine like terms. So it's 4x minus 1 minus 6x minus 2. 4x and negative 6x is negative 2x. Negative 1 and negative 2 is negative 3. You could also get a common denominator and add those up. You would still end up with a negative 2x minus 3. Number 13. What we have here is an equation with fractions, and because fractions are not, preferable to work with, we could get rid of them. To clear the denominators, or to get rid of the fractions, we need to multiply by the LCD. Now, the fractions we have here have a 5, a 2, and a 10 in the denominator, so the LCD of those three numbers would be 10. So if I multiply everything by 10, it should clear the fractions. So 10 times 2/5 x would be 4x. 10 times negative 1/2 would be negative 5. 10 times 3 would be 30. And 10 times negative 3/10 x would be negative 3x. As you can see, I no longer have any fractions, and it's pretty straightforward to solve for x. I would add 3x to both sides. I would get 7x minus 5 is equal to 30. And doing my order of operations, or solving for x, I would get x is equal to 5. Number 15, solve for x. To do this, we want to subtract the c first. And because p is multiplying the x, we need to divide by p on both sides to get rid of the p. So x is equal to k minus c over p. Number 17, we need to distribute in this negative 1 on the left side. And then we just need to combine like terms. So negative 2x and positive x is negative x. Positive 4 and negative 4 is 0. So the left side simplifies to negative x. And then I have my less than symbol, and on the right side, 2x and x is 3x. Negative 1 and negative 3 is negative 4. Now we would go ahead and add 3x to both, Now we would subtract 3x from both sides. And then we would divide both sides by negative 4. Now remember that if you ever multiply or divide by a negative when you're dealing with inequalities, you have to flip the sign. So since I divided both sides by negative 4, I need to change the less than sign to a greater than sign. Negative 4 divided by negative 4 is 1. So x is greater than 1. Number 19. First thing I need to do on the left side is distribute in this negative 2. So negative 2 times 5 is negative 10. Negative 2 times negative 2x is positive 4x. Then I have a greater than or equal to sign. And what we want to do is convert this 3.5 to an improper fraction. We do that by multiplying 3 times the denominator, which is 6. And then we add the 1 in the numerator, so that's a 7. So 3.5 is equal to 7 halves. So instead of writing this as 6x minus 3.5, we're going to write it as 6x minus 7 halves. On the left side, I'm going to go ahead and combine like terms. So I have negative 10 plus 5x. And because we don't really like to deal with fractions, we can get rid of the fractions by multiplying everything by the LCD. The LCD in this case is 2. So multiply everything by 2. 2 times negative 10 is negative 20. And then when I multiply the 2 on the right side, I get 12x minus 7. Now we're going to go ahead and subtract 10x from both sides. Then we're going to go ahead and add 7 to both sides. Then we're going to divide both sides by 2. Now, our answer is that negative 13 halves is greater than or equal to x. But be aware that on a test, typically the x is going to be listed on the left side. So we got to make sure that our inequality is pointing the right direction. The greater than, or the openness, the open mouth is pointing towards the 13/2. So we want to make sure that we flip the sign so that it is facing the right direction. It's the same as writing x is less than or equal to negative 13/2. Number 21. To solve for x, what we need to do is first add 7 to all three parts of our inequality. So we get 6 is less than 2x is less than 8. Then we want to divide everything by 2. So we solved for x, and our inequality should be 3 is less than x is less than 4. Absolute value equations. If we have an absolute value equation, what we want to do is split. Split this into an x is equal to positive c and x is equal to negative c. So for number 23, we want to split this and write it as 8 minus 2x is equal to 6 and 8 minus 2x is equal to negative 6. Then we have two equations. We want to go ahead and solve for x. So subtract 8 from both sides and then divide both sides by negative 2. On the right equation, we want to subtract 8 from both sides and then divide by negative 2. If we were asked to graph this, it would be a number line. It would be two solid dots. The dot on the left would be the smaller number, which is 1, and the dot on the right would be the bigger number, which is 7. Before we split this equation, we have to isolate the absolute value of 2x, which means we have to subtract 8 from both sides. Then we would have to divide by 4. So now that we have the absolute value all by itself, we will now split. So I get 2x was equal to positive 1 and 2x is equal to negative 1. Now we would divide both sides by 2. And we would get that our answer is x is either equal to positive 1/2 or x is equal to negative 1/2. 27. Similar idea, we want to isolate the absolute value, so we subtract 1 from both sides. Then we would divide by 2. Now, when we have an absolute value of a number greater than a value, we want to split these as well. So we're going to say x is greater than c, or x is, we want to flip the sign and make it negative, or x is less than negative c. So now that we've got the absolute value isolated, we want to split this as x plus 4 is greater than 5, or x plus 4 is less than negative 5. Then we would go ahead and solve for x, so we subtract 4 from both sides. And we would get that x is greater than 1, or x is less than negative 9. When you graph, if you were asked to graph, you would use an open dot because it's a strictly less than, and you would point your arrows or shade your arrows outward. So greater than is like oars of a boat. The smaller number goes on the left and the bigger number goes on the right. So x is greater than 1 is represented here in our graph, and x is less than negative 9 is also represented. Number 29. Another the greater than, so what we want to do is split. X is going to be greater than 7, or x is going to be less than negative 7. This particular case, they're asking us to graph, so we're going to use open dot, and we're going to shade our arrows outwards. The smaller number goes on the left, and the bigger number goes on the right. So x is less than negative 7, or x is greater than 7. Number 31, an absolute value equation. So we're going to go ahead and split. x is equal to positive 4 or x is equal to negative 4. And since we're asked to graph, these are going to be solid dots because it's an equation. The smaller number goes on the left and the bigger number goes on the right.